Hi everyone, this is Miss Afric here, and today we're going to be talking about modeling with exponential functions and power functions. So just so you know, today in the video we're going to talk about how to do these types of problems by hand, and then during class your teacher is actually going to go over with you how to do it on the calculator too. So we've got two different methods. We'll do the by hand method here and then the calculator one in class. So just make sure you know how to do both for the test coming up. Alright, so in order to figure out how to model with these types of functions, we have to make sure we know what they are. So exponential functions, that's what we've been doing this chapter. That's the kind of function that will look like y equals a times b to the x power, right? Where a and b are just constants. And this should look familiar because these are the types of functions we've been seeing throughout Chapter 8. And just some examples of these kinds of functions so that you can kind of recognize them would be something like y equals 2 times 3 to the x power. That would be an exponential function. Or another one that's probably more familiar to you based on what we've been doing this chapter, something like maybe a equals 2,000 times 1 plus 0.05 to the t power. Right? That should look pretty familiar. That's just an exponential function. Now, power functions, they're very similar. The main difference is that over here we have a variable in our exponent. In a power function, instead, we've got y equals ax to the b. So our variable is actually our base, and then we just have a constant up in our power. So again, here a and b are just constants. And some examples of these types of functions, power functions, are something just like y equals 5x cubed, or y equals, negative 2x to the 1/2. Those types of functions. And those we saw last chapter, actually, when we were talking about function operations and domain. So notice how these functions are very similar, but we are going to have to be able to tell the difference. So just make sure you recognize if it's an exponential function, that means our x is in the exponent. Right? If it's a power function, that means our x is our base. Hopefully that will help you remember that. Alright, so let's go ahead and get to some examples. In number 1, it says write an exponential function whose graph passes through the given points. And then it gives us 2 points. Well, the first thing and the most important thing to recognize is they said an exponential function. So just as a reminder, exponential function should look like y equals a times b to the x power. Okay, that's important to make sure you know. Exponential, so that means it should look something like this. Well, over here with these 2 points that they gave us, what we're actually going to be able to do is take these 2 points, come up with 2 different exponential functions, and then solve that system. So, in case you can't recognize that, here are 2 points. We have x and y, and an x and y. So we can just substitute those into our general equation to get 2 different equations. So for the first one, we would have 7 equals a times b to the first power. That's with this first point right here. And then our second equation would be 63 equals a times b to the third power. Again, we're just plugging in our x and y values into this exponential function. And now you can see we have 2 separate equations, which means we have a system, and we can just solve the system. So my first step in solving is over here in this equation, I'm just going to solve for a. So 7 equals a times b to the first, that's the same thing as 7 equals just a times b. So I'm going to divide by b in order to give me a equals 7 over b. And once I've found a, I can substitute that into my second equation to give me 63 equals 7 over b. I'm plugging that in for a, times b cubed. Now, hopefully you recognize that when we're multiplying by b cubed over here, it's the same thing as multiplying by b cubed over 1. So I can just multiply straight across. So I have 63 equals 7b cubed divided by b. B cubed divided by b just gives us b squared. So I have 63 equals 7b squared. Divide by 7 to give me 9 equals b squared. And then I take the square root of both sides, and that's going to leave me with b equals 3. Now some of us might be saying, wait, but you're taking an even root. Shouldn't that be a plus or minus 3? And normally, yes, that is absolutely true. In these kinds of problems, we're just going to take our positive answer in order to get this function. So now I have b equals 3. I can go ahead and substitute that in for my b value over here. So that's going to give me a equals 7/3. So now, again, I haven't finished. I did solve for a and b, but I need to actually write this exponential function. So I'm going to take my a and my b, plug it into this function, and that's going to give me y equals 7/3 times 3 to the x power. And there's my exponential function. Right, so it's very similar to the types of problems we've done before with linear functions and quadratic. It's just this time it's an exponential. Alright, let's keep going on to example number 2. Let me erase this so we can read it a little bit better. Alright, in example number 2, it says write a power function whose graph passes through the given points. So this time we are writing a power function. So just to remind you, power function, that means it should look like y equals a times x to the b. Okay, again, it's important to know what an exponential function is and what a power function is so that we correctly substitute in our x and y values. So taking a look at number 2, once again, we have two sets of x and y values. So I can go ahead and substitute those in. So I've got 8 equals a times 6, which I'm plugging in for x, to the b power. That's my first equation. The second one, I'm going to use the second point, so it's going to give me 36 equals a times 12 to the b power. Once again, we're taking these x, y values and just substituting them in for x and y here to give us our two separate equations. Now over here, I'm going to solve for a. So in order to solve for a, I have to divide by 6 to the b power. So that's going to give me a equals 8 divided by 6 to the b power. And I'm going to take that a value and substitute it in for a into my other equation. So I've got 36 equals, and then instead of a, I'm going to put 8 divided by 6 to the b power times 12 to the b power. Once again, hopefully you recognize that this 12 to the b power is really just 12 to the b power over 1. So I can multiply straight across to get 36 equals 8 times 12 to the b divided by 6 to the b. Now what you hopefully recognize based on our exponent properties from last chapter is right here I have a 12 to the b divided by a 6 to the b. Well, technically, let me scroll down real quick. I could rewrite that as 36 equals 8 times 12 over 6 to the b. Right? Because they have the same exponent, I can combine them together and just divide. So I'm going to get 36 equals 8 times 2 to the b power. And once again, I'm trying to solve for b. So let's keep going with this and solve for b. I'm going to divide by 8 on both sides. And what that is going to end up leaving me with in that problem is I've got a 9 divided by 2. That's the simplified fraction when I do 36 divided by 8. And over here I'm just left with 2 to the b. Now we've seen these problems before. This is one of those exponential problems. Since we have our variable in the exponent, we're going to have to use logarithms to solve this, because a logarithm is the inverse of an exponent. So because my base over here is 2, I'm going to want to make it a log base 2. A log base 2 of 2 to the b, so that those will end up just giving me, or canceling out. Which means over here I also need a log base 2 of 9/2. So let me just swing this up here so we can keep writing. On the left side, I'm going to rewrite that so that I can use my change of base formula to type it in my calculator. So that means I would have the log of 9/2 divided by the log of 2. And over here, log base 2 of 2 to the b. Well, those are just going to cancel out. We're just left with b. And then we can go ahead and type this into our calculator. Be careful with those parentheses. And we should end up getting b to equal approximately 2.17. So I'm halfway there. I've got my b value. Then I'm just going to go ahead and take that and substitute it in for my b value over here. So a equals 8 divided by 6 to the 2.17. I can go ahead and type that into my calculator as well. And I should get approximately 0.164. So you can see now we're dealing with decimals, but that's okay because we're just going to put these numbers into an equation. So we're trying to write a power function. Just a reminder, that's this kind of function up here. So we've got our a value and our b value. That means our final function, I'm going to write it over here, gives us y equals 0.164 times x to the 2.17. And that's our final power function. And I know it seems like there are a lot of steps involved in order to write this function, but we're just solving a system of these two original equations and just using what we've learned this chapter about how to solve exponential equations and applying that to solving a system. So it's good practice for you. Alright, well, when it comes to number 3, I'm going to actually save that one for class, for you guys to try it in class, and maybe to try it on your calculator so that you can see that other method that we got for writing these exponential functions and these power functions. So don't forget, we will be learning that calculator method in class. Well, if you were confused on anything from this video, please make sure you go back and try and watch it again before class. And if you're still confused, just jot down any of your questions so that you can remember to ask them later on. I hope you enjoyed the video. Have a good rest of your night.